So I wanted to wrap up 8.5 with just making sure the last problem we did in class, I always feel like the last problem is rushed, that we go through it in a little bit more detail and make sure we're good. So this was exercise 2, and this was textbook number 29. And the series we were looking at was this. And look at the highest terms, and it looks like k squared over k cubed, right? Because these terms, these constants that are subtracted or added, are negligible. So algebraically reducing that, this is 1 over k, which is a p series, which we know that specific one is a harmonic, and it diverges. So we're not sure if it's smaller or bigger. You could always use, if you're not sure, right, if it's smaller or bigger, you could always use the limit comparison test, and that's what we're going to do here. I just can't grasp whether it is or not. So look at the limit comparison test. And what the limit comparison test does is you take the ratio of the series that you want to compare it to, the known series. So in this case, the series, the unknown series is in the numerator, and I told you in class that the denominator should be the known series. Okay? Algebraically reducing this, you get k times k squared minus 1 over k cubed plus 4. So let's look at that limit. The best way to approach this limit is by dividing through by the highest term, highest degree term in the denominator. Let me just distribute in that term. And the highest degree power in the denominator is 3. So we're going to divide everything through by that. So L is the limit as k goes to infinity. Each term, oops, that's a negative. Negative 1 over, 1k over k cubed divided by k cubed over k cubed plus 4 over k cubed. Now we know that this is going to go to 0, and this is going to go to 0, and these are just 1. So this equals 1. So since the limit, since L is less than infinity but greater than 0, the series is going to converge or diverge as the comparison series. So then, let me write that down. The series will converge or diverge as the known series. I'm waiting for my new stylus to come in. Okay. So having said that, because we know that this is a harmonic and it diverges, therefore the original series is going to diverge. So that's how you use the limit comparison test. So this is going to diverge because 1 over k diverges. Okay, so that's a wrap-up of the problem for the limited comparison series, and that was example 2. You know what, maybe I'll string along example 3 just to make sure we're good. Example 3 was textbook number 31, and this one's a little bit easier and quicker. The series we're looking at is k to the 3/2 plus 1. So here you can just use the straight up comparison test, because 1 over k to 3/2 plus 1 is less than 1 over k to the 3/2, which we know converges by the p-series. So therefore this series is going to converge. All right. So it converges. Right? Remember, p greater than 1 converges. Okay, so that was a straight up comparison test. Hopefully that helps you finish up your homework.